An exemplary complex RC circuit with one capacitor and one switch here. On this slide we have PSpice version where netlist is created manually. Then a switch is modeled by practically 3 elements. It is a variable resistance, and this variable resistance is controlled by these 2 components. So as you see, it is quite complex to model a switch in this version of Spice. It is much easier in a schematics version. In schematics version in library we have a switch. We have a switch T close or T open at time equals 0. So we may include this switch directly into this circuit diagram. Obviously also we have to then set the parameters of analysis, setup, transient analysis, and final time. And these are results of the simulation. We have to recall the netlist to find number label of this node. Now we have below trace is voltage across this capacitor, and top trace is current that flows through a switch. Okay, well, it is the same current that flows through R2 after closing the switch. Now very briefly, a live version of this simulation. So this circuit diagram has been stored in computer memory. We have a switch here. From part browser we may select a switch. It is a part here. We have 2 switches, close and open. Our switch is close, already added here. The setting of this switch, transition time, it is always safe to set this value quite low. 1 nanosecond should be enough. This value should be much less than time constant of the circuit. At the close position, 0.01 ohm should be enough, and 1 mega ohm for open position. Please bear in mind that in open position the resistance of switch is not infinity. Sometimes it really matters. Analysis, setup, transient analysis, and the final time is 1 millisecond. There is no need to add a step ceiling here. These data are stored already in computer memory. Run simulation. Okay, simulation completed. We have a black probe window, so we have traces at first. Trace of voltage across a capacitor. This is voltage at node 2. Okay, and we may add another plot to our window, which is current that flows through resistance R2. Okay, and we have 2 plots that we've been looking for. That way we have completed calculations, simulations for this exemplary problem.